So this is one of the questions that a lot of students find quite tricky. It's based on practical endorsement work, on your practical work, and relies on you having revised ideas surrounding that one, as well as knowing some theory. So the student was asked to carry out an experiment to determine the initial rate of reaction of zinc and hydrochloric acid. They're not giving you an equation here, you're going to have to work that one out for yourself. The student plans to collect a total of this amount. That'll be important. They've given you an amount of something, hydrogen, and to use an excess of zinc. They've got this apparatus, they've given you sizes of things, so you can't weigh out or measure out things beyond this capacities that they're talking about here. They've given you the capacity of the gas syringe, which the 72 fits into. And you've got to outline how they could carry out the experiment and explain how the results could be processed graphically and show your calculations. So this is what's called the level of response question, where you get up to 6 marks. And the mark scheme is based on 3 separate sections when you read the mark schemes for these. So they've usually got 3 separate things to be completed in them. So your 3 separate things are that how are they going to do it, how are they going to process the results, and there's going to be some calculations. So I would go about this way round. I would start with the how. How are you going to do this experiment? So just do the little idiot's guide bit to it. Tell the examiner exactly what you're going to do. You're going to measure a mass of zinc on a balance. You're going to measure a volume of the HCl in a measuring cylinder. You're going to mix them in the flask. You're going to replace the bung, and you're going to measure the volume of hydrogen at time intervals, not just the final amount. We want an initial rate. Now we want to see how this rate is changing over time, so we need time intervals. When we've collected that information, then we will be plotting a graph of volume against time. So we've got time along here, we've got volume up the side, and we would be expecting to get one of these graphs that curves over. We will be drawing a tangent to it at t equals 0 for the initial rate, and we'll be measuring the gradient of that tangent. Volume over time, change in volume over change in time, and that will give us the initial rate of the reaction. You can notice I've done this all in bullet points. This is enough to pick you up full marks. It is an ordered, structured way of showing all your thought processes. I would stray away somewhat from writing an essay on this because you are bound to lose track and it gets confusing. Keep yourself nice and structured. So that's the first 2 parts. The last bit is putting some details into this one. So the details come in the form of knowing the equation. So when you go back to week 1, we were asking you to remember your ions and their formulae, and zinc 2+ is one of the ones that you will have to remember by heart. So the equation is this. The number of moles of hydrogen is the 72 that we had, over 24,000 is that many moles of hydrogen. So zinc is on a 1:1 ratio with this, so the minimum mass of zinc that we would want to put in there is the same number of moles as above times the mass of zinc. So that is the minimum amount of zinc. You need to put more than that in. The volume of HCl then is the exact amount, and HCl is a 1:2 ratio with that hydrogen, so we need twice the number of moles. And using our formula, volume is moles over concentration, we will be able to get a volume, but that volume will be in dm cubed, so we'll need to times it by 1,000, and it gives us centimetre cubed. So that tells us that if we use 60 centimetre cubed and more than that of the zinc, we will manage to get our 72 centimetre cubed of hydrogen. Now let's just go back to this point 1. They never gave us concentration of HCl here. So you should choose a concentration that makes sense, and start with concentrations around about the sorts that we would have been using in class. We often use around about 0.1 mole per dm cubed of substances in class to keep them safe and keep you safe. So in a situation like this, you're going to have to just put in a little bit of a guess and see what your answer comes out as. If you'd put 1 in here, you would have come out with a bit of a silly number here. So you would have then maybe said, oh, that's a bit too small. Let's drop the concentration a bit so that I use a bit more. To get 6 marks on this, then you need all 3 sections completed in detail. You might be allowed a little leeway for the tiniest bit missing, but you also need these in a structured, ordered set of details as you write those through. 5 means you've missed a little bit out somewhere, but essentially it's all there. 4 means that you've either done all 3 but not very well, or you've attempted 2 of them and got all the detail in them well. And 2 means either you've done 2 sections but missed out a fair bit of detail, or you've got 1 section done in good detail.